Operators, an interesting keyword. Let's see some examples. Do you know what this means? You probably do. It's the addition operator, also known as the plus sign. Let's look at few more examples. What do you know what this sign means? You probably don't. It's the assignment operator. Let's look at one more example. Do you know what both of these mean? Well, this is an identity operator and this is a membership operator. All of the examples I showed you are examples of operators in Python. There are many operators in Python, such as arithmetic operators, comparison, logical, identity, membership, and bitwise operators. Arithmetic operators are used for mathematical calculations, comparison operators are used for comparing values, logical operators used for logical operations, identity operators are used to check object identity, which I will explain later in this video. Membership operators are used to check collection membership, that means checking if whether a value or an object is in a iterable or also known as collective data type. And lastly, bitwise operator is used for binary operations. Those are all the operators and their brief introduction. Now let's get into the video and look at some code. So let's understand what are operators. Operators are like symbols and magic keywords that are used to carry out an action between two values. They are like math symbols used every day. They help us to add, subtract, multiply, divide, or any action. For example, like when you calculate the total bill at the restaurant, you can add up all of the prices and then you get the answer to what is the total bill. Similarly, there are many operators present in Python, like I showed you all the types that are used to carry out different actions between two values that give us a different result. So let's first of all look at the arithmetic operators. Arithmetic operators are like the math symbols we use every day. They are the addition, subtraction, multiplication, division operators, as well as operators to find the remainder, and also the power operator. Let's look at these two values. A is equals to 10 and B is equals to 3. If we print A plus B, we will get the answer 13. That is normal addition. Similarly, subtraction gives us 7. This is the sign for multiplication. We do not use X, we use the star symbol for multiplication. It will give us 30. And division is done by the forward slash, which will give us 3.33 division. And if we use just a single forward slash, it will give us the answer in float, which means decimal. And if we use two forward slash, it will give an answer in integer. As you can see, if we use one forward slash, it gave us 3.33, and if we use two forward slash, it gave us just 3. And the percent sign is used to find the remainder, also known as the modulus sign. So if we divide 10 by 3, the remainder will be 1. So it will give the answer of 1. And this symbol is used to raise a value to a certain power, and it is two star signs. One star sign is used for multiplication and two star signs are used for exponentiation. For example, if we raise 10 to the power of 3, it will give us the answer of 1000. So now let's look at comparison operators. Comparison operators, also called relation operators, find the relation between two values. They are used to compare two things and give the answer either true or false. If you have watched my previous video on data types, these are Boolean data types, and they are used to, these operators used to check if two values are the same, different, bigger or smaller. For example, comparing two exam marks to see who scored higher is an example of a greater or equal to operator. And then we have two values, x equals to 5 and y equals to 10. This operator, there 2 is equals to sign, is an assignment operator. 1 equals to sign is an assignment operator, and 2 equals sign is an comparison operator. When we do x, 2 is equals to sign y, it checks if x is equals to y, which we can see it is not, so it will give the value of false. And if we remove 1 equals to sign and add an exclamation mark before it, then it will turn into a not equal to comparison. For example, we are checking is y not equal to x, so it is not equal, so it will give the value of true. And this is the greater than sign, this is the less than sign, this is the greater or equal to sign. So when we check x is greater than or equal to 5, this will give true because there's an equal to. If we just did x equal to x greater than 5, then this will give false because x is 5. But when you use an equals to sign after the greater than sign, it gives true because it checks greater than or equal to. Similarly, this is the less than or equal to sign, and this will give false because y is greater. So those are all the comparison operators. Next we have the logical operators. Logical operators are conditions, and they are mainly used in if-else statements and else statements. If you know those, if you don't worry, I will explain it. So logical operators decide whether a condition is true or false. They also give a result in true or false, just like the comparison operator. The examples are and, or, not. For example, logical operator is I will play football if it is sunny and I have finished my homework. So we have two conditions. If it is sunny and, so if we look at this form and perspective of the logical operators, the and is used to indicate that both of these conditions have to be true. It has to be sunny and you have to have finished your homework to be able to play football. Now let's look at some code. P is equals to true and Q is equals to false. We check P and Q. This means we are checking that both values should be true. If we had, for example, and use a comparison operator, 8 is greater than 5 and 5 is greater than 3, then this is an example of both a comparison and logical operator. First we check the comparison and this will give true, and then this again will give true. So both of these will be true, so the answer overall answer will be true. Let me help you picturize it. This will give true and this will also give true, so the overall answer will be true. So AND operator basically checks if both values are true, then it will give true, but even if one is false, then it will give false. And or on the other hand, if you to check if even one value is true, it will give the answer as true. For example, if we did here 2 greater than 3, then this will turn into false, but the overall answer will still be true because the or operator just checks if one value is true, so it will give the answer as true. But if all of the values are false, then it will give false. Next we have the not operator. Not is used to invert invert a value. For example, let's take not 5 greater than equal to 8. 5 is not greater than or equal to 8, so this will give a value of false. But the overall answer will be true because the not operator just inverts the answer. For example, this condition gave the answer of false, but when we applied not, this changed to true, so the overall answer became true. So true was printed. Next we move on to the assignment operators. Assignment operators are used to put a value inside a variable and sometimes update it at the same time. For example, an equals to sign is an assignment operator. We are assigning a value to a variable, and it can be any value. We can assign a string, we can assign a boolean, we can assign a float, integer, anything. When we assign a value to a variable, we use the equals to assignment operator. And you can also assign and calculate both at the same time using these operators: plus equals to, minus equals to, star equals to, forward slash equals to. These are all assignment operators. These are the same if we look at the plus equals to. If we write num plus equals to 5, this is the same as num is equals to num plus 5. Num is 10, so 5 will be added, so it will become 15, and then 15 will be assigned to the variable num. So when we print the num, 15 will be displayed. Same goes for the minus equals to sign. 3 will be subtracted from 10, and then we assign to the num variable, and then when we print num, so it will be 7 instead of 10. Same goes for the star equals to, this is used to multiply and assign. Forward slash equals to is used for dividing and assigning as a float. This is used for dividing, assigning as an integer. It's used to remainder, assign a remainder. So when we use num modulus 2, so 10 will be divided by 2 and the remainder will be assigned to the variable num, which will be 0. And this is the exponent equals to operator. It's used to raise to a power and then assign. So those are basically assignment operators used for assigning values, and you can also carry out calculation along with assigning in just a single operator. Next up we have the bitwise operators, and these are a little bit more complex, but stay with me, I will make it easier. These work, all of the other operators we looked at work at the top level. They, for example, we have a value of 5 and we add 3 to it, 5 plus 3, it will become 8. That works at the top level. It doesn't go into binary or hexa. That just works at the top level in binary numbers which we humans understand. But bitwise operators are used to carry out calculations or comparisons on a binary level which we humans don't understand. But binary is the language used by computers. So these are also operators are powerful tools. They used to manipulate numbers and find out certain comparisons. And you can also shift the bits around. So if you don't understand binary, let me explain it to you. So binary is the language used by computers, like we humans use normal numbers like 5, 300, 1000, million. These are called binary numbers, but computers don't understand them. If we have to give any value to a computer, we have to convert it into binary first, which is made up of only two digits, 0 and 1. And you can think of these digits as a light switch. When you turn on a light switch, it gives the value 1, and when you turn off a light switch, it gives the value 0. So let's, and an example of a binary number is 1010. That's a 4-bit binary number. If we add another 2 digits, it's 6-bit. Another 2 digits, it becomes 8-bit. Binary works in powers of 2, just like the numbers we use work in powers of 10. For example, we have 100, the number 100. It uses powers of 10. This is 10 to 2 power. The first is number 1 is the value of 10 to the power of 2, which is 100. This value represents 100, and then this is 10 to the power of 1, which represents 10. It has the value of 10, and this represents 10 to the power of 0, which is 1, and this value represents 1. Similarly, binary numbers work in powers of 2 instead of powers of 10. The first digit has the value of 2 to the power of 0, which is 1. So if we just look at all ones, then the, then the first digit will have the value of 1, and then so let's calculate. First digit will have the value of 1, then the second digit will have the value of 2 to the power of 1, which will be 2, so it will be 2, and then the third digit will be 2 to the power of 2, which will be 4, so it will be 4, and the last digit will be 2 to the power of 3, which will be 8. So the maximum uh, value a 4-bit binary number can hold is 15, which gives this answer. And if we continue, and so this will be 2 to the power of 4, which will be 15, 2 to the power of 5, which will be 32. So if we will add plus 16 and then plus 32, and if we switch any of these to a 0 like this, then we don't calculate the powers of 0, we only calculate the powers of 1. For example, first all of these numbers are 1, so we use to calculate or to use all of the powers, but when there is a 0, we don't use those powers. So there is a 0 here, it has the power of 0, so 1 will not be added, so we can remove that. then there is a 1 here, so 2 to the power of 1, 2 will be used. Then there is a 0 here, to 2 to the power of 2, which is 4, will not be used. Then the rest is 1, so they will be used. This will give an answer of 32 plus 16, 48, then 54 and 56. So the total value this binary number holds is 56. Now let's get back to the operators. So once we understood binary, we can represent these two values in binary. There will be 0, 1, 0, 1, which is 2 to the power of 0, which is 1, and then 2 to the power of 2, which is 4, so 4 plus 1, 5. Then there is 3, which is 2 plus 1 equals 3. Now let's look at the operators. This operator is the AND. This operator only keeps matching ones. So if we look at these two binary numbers, let's see where both of the values have ones. It is only in the first place. This doesn't have one, this doesn't have one, and they both are zeros. So the answer binary number will be 0001, which equals to 1, because this is 2 to the power of 0, which equals to 1. So the AND operator only keeps matching ones, but this, which is a line, is the OR operator. It keeps the place with at least one. So if we look at these two binary numbers, this both digits have one, so this will be 1, and this at least has 1, so this will be kept, and this one has at least 1, so this will be kept, but this one has both zeros, so this will not be kept. So the answer binary number will be 0111 equals to 7, because this will be 2 to the power 01 plus 2 plus 4, it equals to 7. Next we have the power symbol, which is used in the real world but it is not used in Python. This is instead used to represent XOR, which is if bits are different. So let's look at the code. There is matching bits 1 and 1, so this will not be kept, this will be 0. These are different bits, so this will be kept, and these are different bits, so this will be kept, but these are matching bits 0 0, so these will not be kept. So the answer binary will be 0110, which equals to 6, because 2 to the power of 2 plus equals to 4 plus 2 to the power of 1 is equal to 6. Next is this operator, which is the NOT operator, which is to invert. This is another concept to complement, but I will not explain it fully. Just look at the code, and these are two values. So first we use the NOT operator on A. So we have 0 1 0 1. We will just invert the values. So this will become 1 0 1 0. But one more thing will be added. Previously we had 2 to the power of 3, which equals to 8, but now this last place will become negative. So this will be minus 8 plus 2 to the power of 1, so 2. So this will become minus 6. Minus 6. So, and that is the answer we have written here. Next we have the left shift, which is used by two left hand sides, and the value here will be how many it is shifted by. This is another concept in binary, but I will not explain fully. So when we shift a number to the right, it will lose the leftmost bit, and a 0 will be replaced on the right. For example, if we have done A to left, shifted to the left one time, so it will be answer will be 1 0 1, and a 0 will be added at the end. So we lost this leftmost digit, which is 0, and all of these other digits were shifted in its place, and then a 0 was added at the end, so it became 1010, which is the answer of 2 to the power of 3 8 plus 2 to the power of 1, which is equal to 2, so 10 will be the answer. But one thing to remember is you can only shift as much zeros are on the side which you are shifting. For example, we shifted to the left and there was only 1 0, and if we shift it 2 times, the value will not be the answer which we were expecting. For example, let's try, we shift to 2 times, so this will become 0101, so this will become 0101, and the answer will be 2 to the power of 2, which is 4, plus 2 to the power of 0, which is 1, so 5. It will be 5, but that is not the answer we were expecting. because when we do a left shift, we are actually multiplying the number by 2. So the original number 5, if we do one left shift, it will be multiplied by 2, which is 10, which we got the original answer. But if we do another one, we were expecting it to be 20, but we got 5 because there was only one 0 here. We can only do left shifts or right shifts as much as zeros are on that side. So it's a little bit confusing, but you don't need to go very deep into it. So let's just understand, or you can only do left or right shift as much as the zeros are on that respective side. And right shift is the same as left shift, but the one key difference is in left shift you multiply the value by 2, and in right shift you divide by the value by 2. Next we have the identity operator. These people will say are similar to the assign or comparison operator, especially is and the two equals to sign. People will say these signs have the same meaning. You are both used to check if a value is both two values are equal, but they are wrong. Actually, the equals to sign is used to check if two values are equal. So both these lists are equal, but if we do the same list 1 is list 2, this will not give the same answer, because identity operator used to actually check the memory location. If two objects are in the same memory location, then the answer will be true, otherwise the answer will be false. For example, imagine two identical looking water bottles. They may look the same, but they're two separate bottles. They occupy two different locations, two different areas. If we create a reference of the water bottle, for example, we take a picture. It we are using a reference of the water bottle, and if we check the picture is the water bottle, then it will be true because we are just referencing it. In the phone there isn't a water bottle, it's just a reference, it's just a picture of the water bottle. If we want to access it, we have to go get the water bottle from the table. If we check list 1 is list 2, that will get false because even though they have the same values, they don't occupy the same memory locations, so it will get false. But if we created a reference of list 3 equals to list 1, so we actually didn't create a separate object, we just referenced it. So if we print list 3, it will reference to list 1 in the memory location and print it. So if we check list 1 is list 3, it will become true because both these variables hold the same value in the same memory location. And we use the not operator here, so which is used to invert the answer. So if we check list 1 is list 2, which will give false as seen here, it will invert the answer. So false will be turned into true. So it will be used. So it is used to confirm if two values occupy the two different memory locations or they are two different objects. Finally, we have the membership operators. These are used to check if something exists inside a collection of things like a list or a group. For example, we have a list here 1, 2, 3, 4, 5. If we check 3 in the variable nums, which is this list, so we can see 3 is present. So the answer will be true. If we check 10, it will give false because 10 is not present. And we use this not operator here also. So not operator is used in many different type of operators. It will invert or reverse the answer. So 7 is not in num switch, so it will give false, but we use the not operator, so it will be inverted, so it will change into true. False will be changed into true, so the final answer will be true. But if you look at 2 in nums, it will give true, but we use the not operator, it will become false, and the answer will be false. So those are all the operators. So now let's look at some actual examples to understand how you can use them. First, we have the example of a student report system. There is just math. So there are two subject marks: math 85 marks and science 90 marks. First, we can apply arithmetic operators. If we add both of the marks together, the answer will be 175. You can see here 175. And if we divide the total by 2, which will be 175 by 2, then this will give the answer in float, because if we use one forward slash, it will give in float. If we use two forward slash, it will give it as an integer. So the answer will be 87.5. And we can also use comparison. We are checking is math greater than science. So we can see here 85 greater than 90. This will give false. And if we are checking if they are both equal, which they are not, so this is also false. Logical operator, math greater than 40 and sign greater than 40. So if both of these comparisons give true, then the answer will be true, and both of them are greater than 40, so this will give true. And this is to check both passed both subjects. So a real life example. And assignment operator, we are assigning 5 to the variable bonus, and plus is equals to bonus. We are first adding 5 to math, which is 85, so it will become 90, and then we are assigning the 90 value to math, so it will become 90. And membership operators, if there is a list of subjects and we are checking if English in the list, and that is apparent, and so the answer will be true. Next we have the identity operators. Does B have the same identity, or does B occupy the same memory location as A? So the answer will be 2, because we are just creating a reference of A. So when we print B, it will just look at A in the memory location and print it. Next we are checking is A equal to C, which will give false, because there are both two different objects that occupy two different memory locations. Finally, uh, we have x equals to 6, y equals to 3. We are applying bitwise operators x and y. You can see here, and this will give 0, this will give 1, and this will give 0, so the answer will be 0 1 0, which will give 2 to the power of 1, which is 2. And we are applying the OR operator, checks if at least one bit in both numbers is 1. So this is 0 and 1, so this will be 1. Both are 1, so this will also be 1. And that is 1, so this will be 1. So this will be 1 1 1, which is 7. So that was a real life example, and I hope you guys enjoyed this video, and I hope you learned something, and hopefully you have become a master of these operators, and you will use them in real life coding projects. And if you did like this video, so please hit the like button, subscribe to my channel, and I post similar videos to these explaining different concepts in Python. I will also upload different projects in Python, and I also explain different applications and give tutorials on different applications and also PC parts. So if you're interested in any of those, consider subscribing, liking, and if you didn't understand any operator, please comment down below. Comment down below which operator did you find the most confusing, identity, bitwise, or the membership operator. Personally, I find the bitwise operator confusing. So yeah, this is the end of the video. Take care and bye.